Following on from some of the earlier videos, we still need to understand more about this thing here, because this thing here is a lot more complicated than it looks. If k here is 2, if k here is 2, if k here is 2, then it's nice and simple to understand. But then if you have negative 2, then it becomes 1 over 1 plus x squared. You see, when k is 2, it's nice and simple to understand. But when it's negative, then it becomes something totally different. This is totally different from this. If you have to the power of 3, that's nice and simple to understand. Or 4, it's nice and simple to understand. But when it's negative, then it becomes something totally different. This thing here is totally different from this. So we still need to understand more about this thing here. It is actually a lot more complicated than it looks. So we've seen that this will generate this series. So we generate this, and then up into x to the power of n, it will then give us this, and then all the way to infinity. So we've seen this. Well, if you look at x to the power of n, well, this thing here, this coefficient here, turns out to be exactly the same as this thing here. So these two are exactly the same. And later on, I will try to explain why the two are exactly the same. But as it turns out, this thing here is exactly the same as this. And hopefully we've seen this in the past. Hopefully you would recognize it. This thing here is actually the same as this. And then, so for general x to the power of n, this coefficient here is exactly the same as this, which can be rewritten as this. So this whole series here, all the way to infinity, can be written as this, all the way to infinity. So it can be rewritten as that, which is the same as this. So as a reminder, I still need to explain to you why this is exactly the same as this. But as a reminder, let me just try and explain this thing here. Let me remind you. So in the past we've looked at this Pascal's triangle. If I were to give you a plus b to the power of 4, so this is squared to the power of 3 to the power of 4, So I should be looking at this line here. This is just a reminder. You should already know this. So if you were to multiply this out, so the first coefficient would be this. The second coefficient would be this, and this would be this, and so on here. And then there's a button on your calculator that allows you to do 4, choose 0, which will be 1, 2, 3, 4, and then this is 0, 1. So you've seen this before. So punching this into a calculator will give you this. Punching this into a calculator, that will then give you this, and then this will give you this, and so on. You should already have seen this in the past. So hang on. So going back to this thing here, if this thing here will generate this series all the way to infinity, and I'm saying that this thing here turns out to be exactly the same as this thing here. So let's try and understand why this is exactly the same as this. So let's look at a simple case where k. Let's look at a simple case where k is 7. Where k is 7. So this is our 7, and then let's just look at the random term to the power of 5. So we are looking at x to the power of 5 here. So let's just look at a simple case where we've got 7 here and 5 here. So if you look at this thing here, it will be 7, and then minus 1 will be 6, and then minus another one will be 5, and so on. And then if you look at this one here, the last one will be, well, let me just rewrite this as minus n minus 1. So this thing here is always 1 less than this thing here. If you look at this, n is here, this thing here is n minus 1. So if you look at this here, I'm going to reimagine this bit here as being this. K and then minus n minus 1. So if you look at the very last term, it will be k minus, and then this thing here will be 1, this thing here will be 1 less than the n. So if you look at this here, the last one will be 7, will be k here, which is 7, take away, and then 1 less than this. Remember, this is our 5. So that means this is our 5 here. And then this is 1 less, so it will be 4. So this thing here will be 7 take away 4. So the last term will be 3. The last term will be 3. Badly explained, but think about it. So I will continue in the next video. Okay.